So hi Kansha, I guess we'll start in like 5 minutes so that a few others can also join the session. So I'll start discussing about the problems in like 5 minutes. But then I'll just mute myself so that a few others can also join. Okay, so I guess we can start now. So hello everyone. Uh, well, once again, welcome to the third week of the NPTEL Discrete Maths Problem Solving session. So just to reintroduce myself, I'm Lakshya Saggi, the NPTEL Problem Solving TA for this course. And today's session, and so this will be our third session, and this session will be covering problems related to first order like Boolean algebra. So basically, uh, tautologies, contradictions, and like stuff related to uh, Boolean variables and stuff. So yeah, I hope everyone has gone through the lecture videos for this week because like I'll be explaining the concepts along the way, some concepts, but I'll be mostly assuming that you guys already have seen the lecture videos. So we'll focus more on the problem solving part rather than discussing the theory. So I guess we can get started now. I'll just share my screen and like once again, just remind you guys if there are any if there are any technical issues like my screen is not visible or I'm not clearly audible or like you are not able to understand what I'm explaining, then feel free to type out in the chat and I'll just try to resolve your query as soon as possible. So I guess we can get started and I'll just share my screen. So just let me share my screen, guys. Okay. Ojas is saying that I'm not audible. Akansha, am I audible to you? Uh, so maybe it's a fault in Ojas. So maybe I'll just type in the chat for Ojas to try and reconnect. Okay, till then I'll just share my screen. Mm, So okay, so I hope my screen is visible. If it is not, then you can uh, try to reconnect. Like you can let me know via chat and I'll try to resolve it. So today's questions are just once again reminding you that based on Boolean logic. So yeah, I guess we can get started. So the first, just one second, guys. Mhm. Okay, I think we can start now. So the first problem is uh, let P denote this statement that Ram likes ice cream or Sudha likes toffee. So this is the statement which is given to us that Ram likes ice cream or Sudha likes toffee. And we want to find out what the negation of this statement P will be. So rather than just giving you the answer, I'll try to explain it to you guys also. Although this is not a very hard question, but still just to get the flow going. So let us assume that the statement Q, let us say there's a statement Q which just states that Ram likes ice cream. Okay. And then there's a statement R uh, which says that Sudha likes toffee. Right. And now, what does the statement P imply then? So statement P is nothing but just Q or R. Right. I hope this is clear that why statement P is just like the statement P says Ram likes ice cream or Sudha likes toffee. So if Q is a statement Ram likes ice cream and R is a statement Sudha likes toffee, then the statement P is nothing but just this Q or R, right? And so what we need to find out is a negation of P. So what we need to find out is a negation of P. And note that I'll denote the negation symbol by this exclamation sign. So like this is a notation which I'll be assuming. So there are a bunch of other notations also which I'll come to later, but yeah. So sometimes I'll be assuming that I'll write sometimes like A or B. I'll sometimes write it as A plus B also. Like you can think of it as like you can think of the OR operator as Boolean addition because like 1 or 0 comes out to 1. So it is 1 plus 0. Similarly, 0 or 0 comes out to 0. So that's why it's also 0. The only thing is like 1 or 1 comes out to 1, but here we'll assume like 1 plus 1 is 1. So it's just a notational thing, nothing else that I've just assumed that OR is denoted by the plus symbol sometimes, and this AND is denoted by the multiplication, like A and B I'll denote sometimes as AB. And similarly, not of A, I'll sometimes denote as this exclamation and similarly like so something like this. So this sort of expression like P or Q and R will just reduce to something like P plus Q times R. So this is just for our convenience so that we can like we can solve like we can type things faster and uh, like without compromising on our understanding, we are able to understand a solution faster. That's why I just introduced these notations. So what we have to find out is not P, right? We want to find out the negation of the statement P. So how can we do this? We can just state that P we know is a Q or R, right? So this is P is nothing but not of Q or R. And this, what will this be equivalent to? So I think I have I described it in the last week or in last week also, and you guys must have seen it in lectures. So this is something similar to De Morgan's law. This is so what is not of Q or R equivalent to? Would anyone like to point out in chat? This is just straightforward De Morgan's law. Yes, so Akansha is saying that this is equivalent to not Q and not R. So correct, Akansha. So by De Morgan's law, this is nothing but not Q and not R. Right. So I'll just assume that you guys know this. So what does this statement not P then actually mean? So not P is nothing but equivalent to not Q and not R. So what is not Q? So not Q is Ram likes ice cream. So not Q will be like Ram does not like ice cream. And not R means like and Sudha does not like toffee. So note that there was this compound statement like P was a compound statement which had two claims connected by an or, like Ram likes ice cream or Sudha likes toffee. And like while taking its negation, like we just describe P in terms of two simple statements, which can't be broken down further, like Ram likes ice cream and Sudha likes toffee. And now it's easier for us to take the negation. So what will not be equivalent to? So Ram does not like ice cream and Sudha does not like toffee. So this will be the answer for us. I'll just underline it for everyone. So I hope this is clear to everyone, like how did we arrive at this? You can directly see also, like once you have enough practice that Ram likes ice cream or Sudha likes toffee, its negation will just be this or is replaced by and both of these individual statements are negated. That's what I've done here, right? Okay. Then we come to the second statement, the second problem. So the second problem says, okay, so which of the following statements are true? So which of the following statements are true? So first problem is the sentence Rajesh is a hardworking man is a statement. So what do you guys think? Like, is this part? So what do we actually mean by a statement? First of all, so statement is something which is fact based, and which is not a objective base. So I hope you have seen in the lectures like what the definition of a statement is, and like similarly what the definition of a proposition is. So a statement is something which is fact based, and like that fact you can verify. Like it's not an opinion of someone or anything. And a proposition is a statement which is either true or false. So like 2 plus 3 equals 5. This is a fact. This is not an opinion based. Like one person can claim 2 plus 3 is not 5. This is not possible. Like, because in maths, like this is a fact that 2 plus 3 equals 5. So similarly, this statement, Rajesh is a hardworking man. This sentence a statement or not? Like if someone tells me that Rajesh is a hardworking man, is this an objective truth or is this the opinion of the person who's telling me? Yes. So Akanksha and Ojas both are saying that is opinion. So you are correct. So exactly. So since this is opinion based, so this is not a statement. So not a statement. And why is this? Because as it is opinion based, not fact based. Right. So, but let's say someone says that sun rises from the east, then that would be a statement because it is a fact. It is not an opinion, right? Similarly, let's say second thing that 9 is not a prime number. So this is a statement. Although this is false. Okay, so although this is true, sorry, but yeah, so this is true that 9 is not a prime number because 9 is composite. So like we'll come to that whether it is whether it is true or false. We'll come to that later. But first of all, this is a fact-based thing, right? It's a fact-based sentence that 9 is not a prime number. So everybody can see this. So that's why this is a fact-based, and hence it is a statement. Yes, a statement since it is fact-based, right? And similarly, the third sentence says that cardinality of A union B is 5, where A is 1, 2, 3, and B is 2, 2, 7, 8. So you can just see that what's the cardinality of A union B. So cardinality of A union B is nothing but just like we can just claim that what actually is A union B here. We can just write that first. So A union B is nothing but 1, 2, 3, and then these 7 and 8, right? Because in unions, like this 2 is common, so set is in set like every element should be unique. So this 2 will occur only once, and that's why A union B. Like there are 5 elements in A union B, so cardinality of A union B is 5. So this is the statement. So for the final answer, so like so this statement that 9 is not a prime number, this is true, and cardinality of A union B is 5. This is also true. So 2 and 3 are actually statements. 2 and 3 are statements. And in fact, both statements are true. So what I mean is that, okay. So what I mean is actually a statement is something which is fact based. But note that a statement need not necessarily always be truth. So suppose someone says that 9 is a prime number. That is also a statement, but that is a false statement. So if a statement can be verified by facts, like if a sentence can be verified by facts, only then we call it a statement. So let's say if someone had said to me that 9 is a prime number, that sentence, although incorrect, is a statement because I can check the facts And like everybody, I will ask everyone, and everyone will say that this is actually incorrect, that 9 is actually not a prime. But this Rajesh is a hardworking man. Some might say this is true, some might say this is false. So this is more of opinion based. But 9 is not a prime number, or let's say if I just said that 9 is a prime number, this is also a statement. Although it is a false statement, but this is a statement because I can ask this same question to everyone and everyone will say that this is false. So note that a sentence which is fact based is a statement, but it need not always be true. Like there can be false statements also. But the main thing is that these statements should be fact based so that we can verify it using facts and not opinions. I hope this is clear and both are true. So here, like it turns out in this problem statement, actually both the statements turn out to be true. So 2 and 3 are statements and both are true. So I hope this what I just said makes sense to everyone. That the 9 is a prime number is also a statement, although a false statement, but it is a statement. Okay, so now let's come to the third question then. So once again, if you have any doubts, like in anything which I am telling or anything else, you can just ask me and I'll try to resolve. You can just type out your doubt in the chat. So yeah. So now let's come to the third question then. Third question is, if A is any statement, then which of the following is a tautology? So let's say A is a statement. So we don't know whether A is true or A is false. Like it is just any statement. Then out of these 4 options, which of the following will always be a tautology? And what's a tautology? So tautology is a statement which is always true. So I hope everyone knows what a tautology is. So tautology is maybe should I write or okay, maybe I should not write because like I hope everyone knows. Or maybe I should just. So what's a tautology? So tautology is a proposition. So once again, like this new term proposition comes up. So if you have seen the lecture, so what's a proposition? Proposition is a statement which can only take the values true or false. Like it will always either be true or false. A statement can be much more than that. We'll come to this distinction also later. I have one question for making this distinction clear also. But for now, let's just assume that uh, it's not a like what I mean here is not a proposition, but let's assume it's a statement. Like a proposition is nothing but a statement which can only take the values true or false. But this did not always be the case. Like a statement is not always a proposition, and we'll see one example of it later on. Okay, so for now, just see this. So a proposition, tautology is nothing but a proposition which is always true, no matter the values of the Boolean variables. So a proposition which is always true, no matter the value of the Boolean variable inside the proposition, is a tautology. Okay. So now let's come to the option and see which of the following options is a tautology. So what is option A? What does option A say? So option A is this upper, this symbol is generally denotes like an or, and this denotes an and. Like at like pointing upwards, this symbol is and this symbol is or. I hope you're clear with this sort of notation. So A or F. So A or F a tautology, like no matter what are the values of the Boolean variables. Maybe I should like replace this by a proposition. Otherwise, it will be confusing to everyone. Okay. Because A is a statement, it might not always be true or false, but if I replace it by proposition, it will always be true or false. So the first question asks A or false. So Would anyone like to answer? Like, do you think that this is a tautology or is this not a tautology? Okay, who just is typing something in the chat. Okay, no. So good job, guys. Akansha and Ojas both have said no. So yes, so this is not a tautology since it is false if A is false. So if A takes the value false, then false or false gives false only, right? So this that let's come to option B then. So option B says A or not A. So is this a tautology? Yeah, it can be like you can just see that this will be. Yes, it is a tautology. Like, and why is this true? Like it can be seen that if A is true, then this part becomes true. So true or false is true only. And similarly, if A is false, then not of A is true. So again, false or true becomes true. Yes, it is a tautology. So one high level intuition is, so B just says that either A holds or not A holds. So this is obviously true, right? Either a proposition will be correct, either proposition will be true, or it will be false. Since A will either be true or false, right? So option B is correct. Option C says A and false. So actually, this is an opposite of tautology because like anything ended with a false is always a false, right? So in fact, this is uh, this is not a tautology, and this is what we call generally a contradiction, a statement which is always false. But let's come to it later. But not a tautology. In fact, this is always false. Right? And similarly, when we come to option D says A and true. So again, like this is also not a tautology because if A is false, then this becomes false and true, which will be actually equivalent to a false. Not a tautology. Maybe I should just. So same explanation will apply. So not a tautology since it is false if A is false. So I hope this makes sense to everyone. So option B is the only one which is a tautology. So I'll just underline this. Option B is the correct answer. Right. Okay. I hope this was clear. Like these are some pretty easy questions in the starting. So we'll come to, so we are just sort of warming up and we'll come to the cooler questions later on. But yeah, I think these are also important just to get the basics correct. So problem 4 says that, so Reena says, it is not that I don't like traveling. So what does Reena actually mean? So what is Reena saying here? So it is not that I don't like traveling. So Reena likes traveling less frequently. Reena does not like traveling. Reena likes traveling, or Reena does not like traveling sometimes. So like we can just see like actually what is this? This is an example of a double negation. Like Reena says that. So if Reena just said I don't like traveling, then we knew that Reena doesn't like to travel, right? But then this is not the case. So it is not the case that Reena does not like to travel. So this means that Reena actually likes to travel, right? So we'll assume that uh, Reena either likes to travel or Reena does not like to travel. Like there are no middle options that Reena likes traveling less frequently or sometimes travels. because then it will be a bit confused. So we'll just assume that either Rina likes to travel or Rina does not like to travel. So first Rina says that I don't, if Rina said I don't like traveling, then it just means that Rina does not like traveling. But it is not the case that I don't like traveling. So this means actually like Rina likes traveling. So this is an example, double negation. So what Rina actually is saying is uh, not of I don't like traveling, right? So this is what Rina says. So, and what is this equivalent to? This is just equivalent to I like travel. So that's why like option C is correct. I hope this makes sense to everyone. Okay, so a lot of you guys already had written option C here. So good job, guys. So now comes the fifth question. So fifth question says that P implies R or Q implies R is logically equivalent to. So generally, how do I like to approach these sorts of questions? So I generally like prefer to like resolve these implication signs in terms of like not and or simple. So I hope everyone knows that like A implies B can be written as not A or B. Right. This is something which you must have seen in the lectures. So what I mean is so P yeah, P implies R. This is actually equivalent to saying that not P plus R. So plus denotes here the or symbol. So actually P implies R is nothing but equivalent to not P or R. Right? And similarly, Q implies R. So there are two statements here, P implies R and Q implies R. Similarly, Q implies R is nothing but equivalent to not Q plus R. Right? So now the question says, P, not P, like P implies R or Q implies R. So this is just equivalent to saying that not P plus R or I'll denote the or by a plus, not Q plus R. Right? So this is what my actual problem produces is equivalent. So this is actually equivalent to just this, like not P plus R plus not of uh, Q plus R. And note that since all of these are pluses, we can just like or is an associative operator. This we discussed last time also, something like this. So we can just remove these parentheses and we can just write it as something like not P plus R plus not Q plus R. So something like this. And the order of taking these pluses, or by pluses I mean ors, this order doesn't matter. And this is okay. So yeah, I'll just be using this symbol for claiming that it's logically equivalent. Right. And what this reduces to the not P plus R and not Q plus R, I can just write it as like I can reorder it as not P plus not Q plus R plus R. I know that R plus R, which is actually equivalent to R. So R and a Boolean variable X or X itself is actually equivalent to X. So this is nothing but so not P plus not Q plus R becomes actually R itself. So this becomes not P plus not Q plus R. Okay, so this is the simplification for this sort of expression. So this sort of expression is actually logically equivalent to something like this. Okay, and we kind of want the solution in some form of this that P and Q should be together and R should be separate. So how can I do this here? So note that this part, not P plus not Q part, can be written as how can I write this not P plus not Q? Claim that I can write it as something like this. That not P implies Q plus R. Does this make sense? Or maybe I should write it as, okay, I think this will not work. But let's just write it as not of PQ, right? This not P plus not Q can be written as not of PQ, right? Because like by De Morgan's law, this is actually equivalent to not P plus not Q. And if I write this as not PQ plus R, then again I see like if I take PQ as something like a Z, PQ, if I replace PQ by a Z, then this is nothing but not Z plus R. And not Z plus R is nothing but Z implies R, right? Where Z is equivalent to PQ. So this is nothing but PQ implies R. I hope this kind of makes sense. And so this is actually option D. P and Q implies R. So hence option D is correct. Right. Okay. So I hope this kind of makes sense. But another thing I just want to tell you guys is that, okay, so I did the derivation in some manner like this. I proceeded along like opening up these, and this is the most simplified form of the expression P implies R or Q implies R, because this just contains or and not negation symbols, right? So this is the most simplified form. And now I just saw that there are many ways to write this thing, right? This is actually equivalent to the original problem statements proposition also. But I kind of wanted P and Q together, so I just wrote it as not PQ plus R, and it just came to PQ implies R. But note that in multiple choice questions, like it might be more than one option is correct, then there might be some other ways to write this expression. Like we saw this as one way, this as another way. So there might be even more ways. So we arrived at one of the options that option D is correct, but it might be possible that more than this, like some of A, B, or C are also correct if the option is like more than one choice correct. So the best way to solve these kinds of problems is like just try out, like if the option is not multiple choice, multiple options correct, then you have arrived the correct answer. But otherwise, the best way is to like see all the options, like reduce all the options to their simplest form. Like we already know, like this is nothing but PQ plus R, right? So that is not equivalent to not P plus not Q plus R. And similarly, like just try to see all of these options and like, just try to open up all of these, like option A, option B, option C, and see like which of the following in the simplest form is actually equivalent to this. And then like you can answer. So while establishing equivalence, the best way is obviously to draw a Boolean table, like the truth table for the Boolean expressions. But truth table takes a lot of time. So to save time, you can just reduce these expressions to these kinds of their simplest forms, from which you can't simplify further, and just check whether the expressions are equivalent or not. Right. So here, like I know this is actually just single option correct. So yeah, option D is the only correct answer. Okay. Kaustav is saying that option C is also correct. Oh, really? Is option C also correct here? P implies Q implies R. I thought that only one. Okay, let us check this, guys. So, what does C option? What does C option? amount to. So option C says P implies Q implies R. So this will be equivalent to saying that not P plus Q and plus R, and we take whole knot of this, right? Because not P plus Q was the expression inside, and we take whole negation and we add R to it. And this will be logically equivalent to. So by De Morgan's law, this will be not of not P plus Q, which will be something like P times not Q, right? And plus R. So I think like P times not Q plus R and not P plus not Q plus R, these two expressions will be actually different, Kaustav. So I don't think option C is actually equivalent. So you can see that if you put here R as false, uh, P as in this expression, if we put P as true, Q as false, and R as false. So if P is true, then not P is false. Q is false, then not Q is true. And if R is false, then this is like false. So false plus false, this will be true. Like what I mean to say is if P is true, if P is false, okay. Q is let's say, what do we put Q? Uh, we can put Q actually anything. Let's just say Q is true. And R is false. Then this expression, the original expression, not P plus not Q plus not R, is actually equivalent to, so if P is false, not P becomes true. So this whole expression will be true, right? But this expression, you can see that if P is false, then this whole part becomes false. And if R is false, this also becomes false. So false plus false becomes false. Hence, option C is not correct. So I hope this makes sense, guys. First up, is this clear? That option C is actually not equivalent. I should just above. Yeah. Okay. So cool, guys. Costa is saying that is clear. Nice. So this is just an additional bit of information that like um, why did I like in the end I had to use some variables like at an instantiation at which I saw that these two expressions are different, but reducing these to their simplest forms actually makes it easier to see like at what values will they be differing. So I just saw that if R is actually true, then both these expressions will actually be equivalent because anything true added to anything will be true. So I put R as false so that these can be differentiated, these two expressions. And then I saw that if P is true here, if P is false here, then this whole expression becomes false. But if P is false here, then this whole expression becomes true actually. So that's how you can distinguish between these two. It's easier to distinguish after reducing these to their simplest forms. Yeah. I hope this is clear to everyone. So moving on, we can go to the sixth question then. Sixth question says that if the truth value S is true, where S is this expression, then we want to know what are the truth values of P and Q, right? What the question says is that what the question is actually saying is this expression is given to us to be true. So if this expression is given to us to be true, what are the truth values at which this expression will be true? So one thing which we can do here is just simplify this expression and see at what values will this hold true or false. Another thing which we can do for this question, at least, like we are I'm just trying to give you multiple approaches so that you can solve the question fastest. Since there are just two Boolean variables, P and Q, you can just check all the four values like P true, Q true, P true, Q false, P false, Q true, and P false, Q false. At all of these four values, at which of these four values does this expression come out to be true? So it can come out to be true at multiple values, but we can just see. So one approach will be, so one approach can be to check for all possible, all four possible values of P comma Q, the value of S. But I don't want to discuss this approach since this is very easy to see yourself and it's a very mechanical approach. Just plug in all the four values and see what the value of this expression comes out to be. Alternative approach can be to actually simplify this expression and then see when will this expression hold true. This complicated expression can be simplified to something because like, yeah, we'll just see how can we simplify it. So alternative approach is simplify the expression for S. And what's the expression? I'll just write this in my notation, like the value of S. S is nothing but not of, not Q and not P. So it is something like not Q times not P. There are a lot of parentheses for you guys. Yes. So not Q times not P, and it says that this implies P. This. Yes. What we have here is not Q times not P first. P2 not Q times not P first. And then this implies P. And we parenthesize everything. I hope this makes sense. Yeah. So now we try to simplify this expression. This is just S. Right? S is equivalent to this. I am denoting this symbol as like the symbol for equivalence of Boolean expressions. So S is actually equivalent to this. It is already given to us, and we'll try to simplify it further. I'll just replace this implication by not symbol. Bear with me, guys. It will be a bit complicated, but maybe I should zoom in a bit so that you guys can see better. Yes, I think this is much better. Okay. So while removing this, what we have to do is not of this part plus P. So I'll replace this by plus and I'll take just not of this part. And what will this be equivalent to? I'm taking not of all of this. So it will be not of the first part, and first part is already a not of something. So this will be a double negation for the first part. So these double negations will cancel out. So first part will just come out to be not Q times not P. And when this not goes here, this will become this will come out. This or changes to and this P again changes to not P. This P changes to not P. I hope this makes sense. And now we see that not Q, not P, and not P, all of these are connected by ANDs. And now, if all of these are connected by ANDs, then it is associative, commutative, anything. So this can just be written as nothing but not P times not P times not Q. Note that is not actual multiplication. I'm just representing these multiplications and additions. I'm just representing ORs and ANDs by these additions and multiplication symbols. And now not P times not P, X and X is actually equivalent to X. So not P times not P is actually equivalent to not P. This will come out to be not P times not Q. And you can't simplify further. And we don't even need to simplify further. If not P times not Q, and we know that this is true, right? This is given to us to be true. If the value of S is true. So we know that not P times not Q is true. And what does this imply? This implies that if and of two Boolean variables is true, then both of these Boolean variables individually have to be true, right? This implies that not P is true and not Q is true. And this implies, and this gives us actually that P is, since not P is true. Okay, maybe I should not use implication symbol, it will confuse you guys, I guess. Not P is true, comma not Q is true. Which means that P is false because not P is equivalent to true, so P is false. Similarly, Q is also false. Right? So this is the only value at which S will be true. What are the truth values for P and Q? So P and Q both are false is the correct answer. Okay, so Kaustav has already written in chat that Kaustav and Akansha both have written that P and Q both are false. They have written as 0. So yeah, good job, guys. It's the correct answer. This is the kind of approach which we can follow. Or like if someone just wants to do everything mechanically, you can do this like this also. Right? Okay, then. Then comes another question of like logical equivalence. I'll just move this to another page so that the question is clear to everyone. Can be clearly seen. So the question again asks not of P or Q or not of P and not of Q. So just assume that it's a single option correct. Like more than one option is not correct. Which of these expressions is actually equivalent to this expression? And you can easily see that this is also not too difficult. This is nothing but not of, I'm just using my intelligence, not of P plus Q plus not of P times not of Q, right? This is the expression which we have. And how can we simplify this? This can be this not of P plus Q can be written as not P times not Q, not P times not Q, right? Because not of P plus Q is nothing but by Riemann law, not P times not Q. And to it, we are adding this expression, which is also like not p times not q only. So if not p times not q is an expression z, then we are just doing z plus z, which is equivalent to z only. So this is nothing but equivalent to not p times not q. And this is the, and you can see that option A is actually this only, not p and not q. So option A is the correct answer. Yes, so Akansha and Costa had written in chat that option A is correct. So good job, guys, again. Option A is the correct answer. Once again, guys, if anyone, I see only 2 people answering in chat right now for all the questions. If anyone else does not have has any doubts or like something is not clear to them, then please ask in chat. I'll try to answer your questions as much as I can, and like otherwise, I'll just have to assume that everyone is able to understand, right? But if everyone is able to understand, then you guys should participate in the chat. So yeah, there's that. Now let's come to the 8th question then. If we are done with the 7th. So question 8 says, what can we infer from the below statement? Gautam will go for a long drive to Mahabaleshwar or he will play cards. And the statement R says that Gautam did not go to Mahabaleshwar. So what can we infer from the below statements? If we just assume that this is, let's just say, I think the option is pretty clear to everyone that the statement Q is says that either Gautam will go for a long drive to Mahabaleshwar or he will play cards. So for Q to hold true, one of these two events must happen. At least one of these two events must happen. And the statement R says that Gautam did not go to Mahabaleshwar. So this event did not occur. So for the statement Q to hold, this statement must occur, right? That he will play cards. And that's why option B is the correct answer. I hope it's clear to everyone why is this the case. Option B is correct. Right? Okay, then. I think this was a pretty straightforward question that Q is true and this only holds true when one of these is true and one of these will be true. But we know that the first part is not true. Second must be true. So yeah. Okay, now comes 9th question. And again, 9th question is again just a Boolean logic based question. It says that if not P implies not Q is false, then what is the truth value of P and Q? Again, we can just see that either you can try all the 4 values for P and Q. I think this expression is simple, so you can get a fast answer using that also. But we'll try to go the alternative route that we'll try to simplify this expression and then see what the answer is. So not P implies not Q, right? This is equivalent to if we take simplification outside, like this implication, like not P or not Q, if I replace the implication with what it means. So A implies B means not A or B. So I'll replace this with plus and I'll do something like not of not B. Right? And this will be equivalent to claiming that P plus not Q. Right? This not of not P. So the double negation will cancel out and this will just remain as P and this will remain as Q. So this expression comes out to be P plus not Q. And we know that this is given to be false in the problem statement, right? And if A plus B is false, then A and B both should be false. This implies that so uh, P is false and not Q is also false, which means that not Q is, if not Q is false, then Q is actually true, right? So P is false and not Q is false means Q is true. So this is the answer for us. And what does this match to? This is like false true, which is option C. Uh, One could have like easily done like trying out all these four options also and see which of these values this becomes false. But as you can see, as you become more comfortable with simplifying these expressions by just replacing these implications and then using laws of Boolean algebra to simplify the expressions, you can arrive at the answer much faster. That's why I prefer something like this. So again, Costa and Kancha had already said that P is false and Q is true. So it's the option C, Akan, not option B. Yeah. Now we can come to the 10th question. Okay. So 10th question now says again, like we have to state whether these two statements are true, uh, like are equivalent or not. Again, one method is just like there are ABCD four variables, and you can just check for like 2 to the power 4, 16 values, like what these expressions, when these expressions take like false, 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 true, when these Boolean variables take different values, and see whether the Boolean table, the truth table for these expressions is equivalent. But we'll again try to simplify these expressions and see what these amount to. Simplifying the expressions, first expression is actually equivalent to, I'll just write it. I'll just remove this implication right away. This becomes equivalent to not A plus B implies not C plus D, right? This expression becomes equivalent to this. Now I can just take this implication also and remove it. Just write it as this is taken negation and we add a plus here. So this is replaced by plus and a negation here. And now not of not A plus B will be equivalent to this not of not A becomes A, and this plus will become like multiplication and A times not B. This will come up to be A times not B, and we had already added this not C and not D, right? Plus not C plus D. So this is what the expression 1 simplifies to. Similarly, expression 2 is something like this. I'll just simplify this. So I'll replace this implication by not A plus C. Similarly, this B implies D by not B plus D. And this then becomes equivalent to removing this implication. I can write it as not of not A plus C plus not B plus D, which will then become equivalent to not of not A, which just becomes A times not C plus not B plus D. So I hope you guys are able to see that these are the two expressions which will come out on simplification for these two, right? And now it's easier for us to see whether these are logically equivalent or not. Although like their formulas we can see are like uh, not same in this manner, but there might be some manipulations by which these formulas can become equivalent, right? So just to be sure that these two are not, it just seems that these two statements are not logically equivalent, that these two will have different truth values for some assignment. But just to confirm our assertions, we should find an assignment at which this happens, at which both of these have different values. Otherwise, what can happen is this expression may be possible to convert this expression into this expression, and we might there might be a way, and we might have skipped that, and uh, that's why our solution can go wrong if we just see what are the simplified expressions values. Like we should find an instance at which these two expressions differ also. And how to find out at what values do this expression differ? If I try to make this expression different, one thing I can see is I should set D to false. Because if D was true, then anything added to it, first expression will also be true and second will be true. What I actually want is these expressions to be false, right? And assignment that these expressions do not agree with each other. At an assignment where one expression is true and other is false, I want such kind of assignment. But if D is true, then both will be true. So one thing I can see is if I want to find an assignment where both of these differ, D will definitely have to be false. And now we also see that if A was true, so I have assumed that D is false, so I can just think that D is not present in the expression. So first expression is A times not B plus not C. Second expression is A times not C plus not B. And now note that if A was true, then first expression becomes not B plus not C. And second expression also becomes not C plus not B. So both these expressions become equivalent if A was true. What we have to do then, we have to put A as false. A will definitely, if there exists assignment at which these two do not agree, these expressions, then in that assignment, D must be false, A must be false. And if A is false, first expression becomes not C, second expression becomes not B. And now it's very easy to find two values at which these expressions do not agree. What are the values of B and C at which this part, not C and not B, does not agree? Anyone would like to answer in chat? It's a straightforward question. Now, these parts of expression are removed because A is set as false. Similarly, this part is removed because D is set as false. First expression just remains not C. Second expression just remains not B. At what value will these expressions differ? Yes. So Kansha says when C is not B at any such value, uh, at any such assignment, these two expressions will differ. So great, Kansha. So just one of the solutions will be when C is true and B set as false. Note that if C is true, then not C will become false. And similarly, this not B when B is false will actually become true. So at this assignment, the second expression becomes true, but the first expression becomes false. At this assignment, one is false, whereas two is true. And hence, there exists an assignment at which these two expressions are different. So one and two are not equivalent. One and two are not equivalent, not logically equivalent. Okay. We have solved this question also. Now let's come to the 11th question then. Or the 11th question is just left it as a try it yourself question. You guys can try it offline. I'll just post the PDF and it's not too complicated. So 11th question, let's just read out the question. Let's see C is a compound proposition involving simple propositions P, Q, and R. C is denoted by C or P, comma Q, comma R. Write a compound proposition P, comma Q, comma R. Write a compound proposition C whose truth table is given to us. Now we are not given the expression for C itself, but instead we are given the truth table for this, for C. That at P, Q, R is true, C will take the value true, at P true, Q true, and R false, this will take value true. What we have to design is we have to design a Boolean expression which satisfies this truth table, which has these values at these assignments of variables. And this is a really standard question. I believe that this is something you guys must have seen in lectures also, a very mechanical way. There are two ways of doing this. One is like writing C in the product of sums form, and the another way is writing the expression as sum of products form. In one way, you just see the rows where the value of C is true, and you try to write on the variables in that manner. And in another way, you try to see at the values where the values of C are false, and then you try to write the expression. I think if you guys have seen the lecture, this question will be very easy for you. So I'm just leaving out this question that you should try this yourself. But one thing to note is that you must be clear with these product of sum form and sum of products form, because these forms help us in various manners, like while deriving the expressions from truth tables, and there are many applications for these forms. So if you have not already learned about seen the lectures about these, then you guys should definitely go and see the lecture. Okay. Now comes the 12th question. 12th question says that consider an expression P implies Q implies not R. This is a Boolean expression which is given to us. And now we want to answer how many rows appear in the truth table for this expression. There are three Boolean variables in this expression. So how many rows will appear in the truth table? Note that this is this is an example of truth table where what a truth table denotes is that at various values of the inputs, what will be the Boolean value of that final expression. There are three proposition variables here. How many possible inputs will be there? Yes. So Kansha has written 8. So that's the correct answer, Kansha. So yeah, since there are three Boolean variables, there are three Boolean variables, and each Boolean variable can take two values, right? Be true or false. The total, so what we have is the total number of possible assignments for the Boolean variables will be 2 raised to the power 3. Possible inputs, and hence 2 to the power 3 equals to 8 rows in the truth table. So we have to write like this. If there were, we should just bold the answer here. Yeah. If there were, like, let's say n Boolean variables in the expression, then there are 2 to the power n rows in the truth table. You guys must have seen it in the lecture also, but just remind you guys again. This is because like every Boolean variable can take two possible values, either true or false, and there are n Boolean variables. So the total number of possible combinations of inputs will be 2 times 2 times 2 times 2 till n, which will be 2 to the power n. Okay, then. So we come to the 13th question then. We are done with like these were like, after this I have like this, these are like 12 questions, and now 13th, and I have two more questions, 13 and 14, and these are a bit more challenging questions. Uh, so I like you guys to try these questions out yourself first, because these are very interesting and challenging questions. I have already pre-written the solutions for these, but I'll share it with you after you guys try it out. First, so this, let's come to the 13th question first. 13th question says an island is inhabited by knights and knaves. Only knights and knaves are present in the island. Knights always tell the truth, and knaves always lie. There are two types of people on the island. One who always tell the truth, one who always lie. And we meet two inhabitants, A and B. We don't know which of these is a knight and which of these is a knave. But when we ask A says that B is a knave. Note that A might be lying if it is a knave, and A might be telling the truth if it is a knight. So A says that B is a knave, and B says neither A nor I are knaves. From these two statements, we want to answer who is a knight and who is a knave. This kind of logical puzzle is also related to Boolean logic, as you can see, because statements are either true or false. One needs a satisfying assignment for knights and knaves, such that all of these statements hold. I'll give you guys like 5 to 10 minutes to try it out yourself first, because I believe this is one of the, like, this is the hardest problem for this session, and yeah, it's a very cool problem. I'm muting myself, so it's 7:23 now. So in 5 minutes, in 5 to 10 minutes, like, I'll answer this question. Till then, you guys should try it out and type in chat whatever, like, whatever your possible approach comes to your mind, or any solution which comes to your mind. You should type it out in chat so that I can never look at it. Okay, guys. So I'm muting myself, and you should try it out this 13th question. If you guys need any hints, just try out all the four possible. There are only four possibilities, right? A and B, there are two residents. So either A is a knight or A is a knave. Similarly, either B is a knight or a knave. There are only four possibilities: knight, 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 knave, 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 and knight, knave, knave, knight. You can try all of those four possibilities and see in which of those possibilities do these statements hold true. This is the high level idea which we'll be discussing in the solution also. So you guys should try it yourself. This is one of the very common interview questions also in general. You guys should definitely try this on your own. Uh, Jay, I'll upload the recording of this session by tonight on the YouTube channel, like uh, which you guys would probably have the link already on. But let's maybe keep the administrative questions aside for now since we are discussing problems. Everything I believe this session's recording and the PDF for today's session, you guys already have the links for this. So let's keep the administrative questions aside and focus on the problem right now. Okay, so Akansh and Costa were typing something. Okay. Akanksha says that A is a knight and B is a knave. Do we have any other answers? Costa was also typing something. Okay. Costa also says that A is a knight and B is a knave. Yeah, actually, good of guys. So both of your answers, both have written A is a knight and B is a knave, and that is actually the correct answer. Maybe I can share the solution with everyone, like just discuss the solution with everyone, like how will this come out? So the high level approach to solving this problem is as I described earlier, right? What I said was there are four cases. A was a knight and B was a knight. A is a knave, B is a knave. A is a knave, B is a knight, and A is a knight, B is a knave. So there are these four possibilities. So we can check all of these four possibilities and see when do these conditions hold true. Maybe we can check case by case. So I'll just, yeah, we'll go through solutions, like the lines of the solution one by one. Let's just assume there are two statements, P and Q. The statement P says that A is a knight, and statement Q says that B is a knight. And what is actually now, like I'm converting this problem into a problem of like a Boolean variables. So the statement P was A is a knight and Q was B is a knight. And what is A saying? A says that B is a knave. A is actually, what does A say then? A is actually saying not of Q, because B is a knight was the statement Q, but A says that B is not a knight. It's a knave. So A says that not Q is true. Similarly, B says P and Q, because what is B saying? B says neither A nor I are knaves. So both, what this statement actually means that both A and B are not knaves. This is what B is saying. So what actually B is saying is that both A and B are knights. This is what B is saying. B is saying P and Q, and A is saying not of Q. And we need to see when does these expressions hold true. Let's just take four possible cases on P and Q. First case is true, comma true, which means that A is a knight and B is a knight. Like I told you, the high level approach that we should take all these four cases. So first case is both are true. In that case, A and B both tell the truths. So this must be true and this must be true. If not of Q is true, A says not of Q and this must be true. If not of Q is true, this means Q is false. But if Q is false, then P and Q is false. Okay, I wrote it here. Q. So yeah. So A and B both tell the truth. This implies not Q is true, which implies Q is false. And what does this imply? This implies that P and Q will be false, right? Because if Q is false, then P and Q will be false. But since B is true, see, we had assumed that Q is also B is also a knight, right? So what B says should be true. So we saw that P and Q should come out to be false, but we also have that P and Q should be true for us, since B is a knight in this case. So we arrive at actually at a contradiction. So this case is not possible. Because one way we say that the statement P and Q is true, and another way we say that statement P and Q is false. That's why this first case is not possible. So at least both are knights is not possible. Then we come to the second case. Second case is, let's assume true, comma false. Maybe I should just give some spacing between these cases. Yeah. Second case says that true, comma false, which just means that P is true, means A is a knight and B is not a knight, so B is a knave. In this case, A tells truth and B tells lies, right? What this means is not Q should be true, as A is telling the truth. So not Q should be true, which means that Q should be false, right? Q should be false. And if Q is false, uh, P and Q will also come out to be false. Right? Maybe Maybe I should just write it down like this. That Q is false, which should imply that P and Q is false, right? And since B was false, so B is a knave here, right? In this case, B is a knave. So what B says should be false. So P and Q should be false. Since P is false, P and Q is P and Q is false. What we have is a consistent solution now. With respect to A, we saw that P and Q should be false. What A is saying with respect to that, and with respect to what B is saying, we also got that P and Q is false. That's why this is a consistent solution and it is a possible solution. We don't know if it is the only solution, but this is one possible solution. Like at true comma false, like when A is a knight and B is a knave, all the conditions are holding true. This is one possible solution. Then we come to the case 3. Case 3 says false true, which means that A is not a knight and B is a knight. So A tells lies, B tells truth. A tells lies, this means that not Q is actually false, which means that Q is true. Q is true, right? Okay, and maybe I should type a solution again. I think these solutions may get you guys a bit confused. Let's just see. So if this was false, comma true, A tells lies, B tells truth. And this means that not Q, what I was saying was false, right? So actually Q is true. And what does Q say? Q says that B is a knight. And we had assumed this to be true. So right until now we are consistent. But now what does P and Q say? P and Q means that A is a knight and B is a knight. We know that P is false. Okay, maybe I should write it better. Since P is false, P and Q is false. But since B is true, P and Q is true. I hope this makes sense that in this case, what's happening is A tells lies, B tells truth. And we know that P is false and Q is true. This much we know. So we know that not Q is false, which implies Q is true. Okay, maybe we don't even need this statement. Yeah, this much is sufficient. That since P is false, what this means is that P and Q is false, right? But what B, since B is a knight in this case, what B says should be true. So since B is true, P and Q should be true. But we also have P and Q is false. So we arrive at a contradiction in this case. Okay, this is getting a bit complicated, guys, but I hope everyone is able to understand. If you're not, just ask me so I'll try to explain it again. And the last case is false, comma false, in which A and B both are lying. In this case, not Q, like what A says is not Q. This should be actually false. Okay. Yeah. A and B both are lying. So A is saying that not Q, but note that since this is a lie, so not Q should be false, which means Q should be true, right? But what does Q say? Q says that B is a knight. But we had assumed that Q is false in this case. So we had assumed Q is false, but we have arrived that Q is true by what A is saying. So yeah, maybe I should explain it like this. But we know that Q is false. So we actually arrive at a contradiction, and hence this case is also not possible. Is this clear, everyone? Like if A is what A is saying is false, so not Q, A says not Q, not Q is false, so Q is true. But actually Q is false in the case. So this is also contradiction. I hope this makes sense to everyone. So out of these four possible cases, only the case true, false was a possible solution, and all the others were not possible. We arrived at contradictions in all other cases. This means that the only possible case is true, false, which means A is a knight and B is a knave. Yeah, one could have just done this logically also, like writing all the statements down and like just checking all the cases directly, but I wanted to focus on the Boolean algebra part of it. That's why I converted everything into Boolean expressions. Yeah, this is what we arrive at. That A is a knight and B is a knave. I just this is the correct answer. A is a knight and B is a knave. So good job, Akanksha and Costa. Now let's come to the last question for the day, which is also an interesting question. So this question will make the difference between what I was claiming earlier, that a statement need not always be a proposition. This is something which I said earlier, right? And this problem will be will you guys will see in this problem, like why was I saying something like that? So the question is quite simple. This suppose someone gives you a statement. This statement is false. Note that this is not an opinion of anyone, right? This is just a statement. It is a fact-based thing. If someone is saying this statement is false, right? So we know that this is definitely a statement. This is not an opinion. So this is fact-based thing. So this is a statement. But now we are asking, is this a proposition as well? Is this a proposition or not? And note that what a proposition is a statement which can either be true or false. So what do you guys think? This statement is true. This statement is false. Is this a proposition or not? Would anyone like to answer in chat? Okay, yeah, since no one is answering in chat, I guess I should just tell you guys, but that's no fun. But can we do? Actually, what you will see is that this is not a proposition. Like, because a proposition is a statement which is either true or false. So proposition can only take two values, true or false. But we'll see that this statement will neither be true nor be false. And why is this the case? I have the solution here. So what's a proposition? A proposition is something. Sorry for that, guys. A proposition is a statement, maybe not something, but a statement, which is either true or false. Okay. So this is the statement which is given to us. let P be the statement that this statement is false. This is the P which is given to us. If P is a proposition, then it must be either true or false, right? And case one, let's say that P is true. Suppose this statement is true actually. So the statement that this statement is false is true, right? But if this is true, what this means is like this part is true, that this statement is false, this is true. But if that this statement is false is true, then what this means is that this statement is actually false, right? So what we get is if P is true, then P is false. Because what we are saying is if this part is true, then this means that this part is false. And so this is not possible. Like this is not a proposition because like if it was, it can either be true or false. But what we claim is like in this case, if it is true, then it is false as well, which is not a property of a proposition. Similarly, in case two, if P was false, if this statement is false, this statement was false, this means that this statement is false, this is false. So note that again we have somewhat of a double negation, that if this statement is false, then it means that this statement is true. So this then we arrive at this statement is actually true. So in this case, what we arrive at as if this statement is false, then this statement is true, which is again not possible. So in both the cases, like P can neither be true nor be false, because if P was true, then P was false, and if P was false, then it was true. What we arrive at is P can't take the value, any of the values of true or false. This means that P cannot be a proposition. This is a very cool little example which makes it clear, like, why do we have to define propositions differently? I'll just leave a note here. Even though P is a statement, since it is not opinion based, P is a statement, right? Because this is not an opinion if someone says this statement is false. It is not a proposition. So statements and propositions are not equivalent actually. This example makes it very clear. That's why I kind of like this example a lot. Proposition is a statement which is either true or false. But this statement is neither true nor false. This is not a proposition. Okay, so this part can be a bit confusing, but if you guys think a little more about it, I believe you will be able to get it easily. But other than then, do you guys have any doubts in this? Okay, so Vastav says there are no doubts and no one else is claiming in the chat. Okay, Gansha also says that it's clear. So good, guys. So yeah, I guess this was the last question which I wanted to discuss for the day. So if no one has any doubts, then I guess we can end the session for today. So once again, just thanks for joining the session, guys. Hopefully we'll see you guys next week also, same time, Monday, 6 to 8. And yeah, if we have like something like 5 minutes, if you have any other doubts, you can ask me, otherwise I'll just close the session. Okay, I guess yeah, I'll stop the recording, guys, and you can leave the session. Thanks for joining the session, guys. Bye bye.